All right, let's continue. So we're still on section 2. We're looking at Riemann sum. Okay, we're going to look at that same graph as before, the square root x. What we're going to do is we're going to see what happens if you increase the amount of intervals. So we made the intervals, 3 intervals before. Let's see what happens if we actually increase. So let's say that we have, let's say that the rectangles are all 1 unit long, and we're going to use, let's say, right-hand rule or right-hand Riemann sum. So we're going to have these rectangles like these. And let's say that we stop at 5. So from 0 to 5. And you can see that we have 5 intervals, right? We have 5 rectangles. We're going to do this very theoretically. So instead of saying 0 to 5, I'm going to call this from A to B. So the size of the interval, which is delta x, is the same, or if we want to figure out the size of this interval, we take the end point minus the beginning, the initial point, and then we divide it by how many intervals there are, like how small we want to slice each interval. That is the size of, or the width of each rectangle. Okay, so then this length is delta x. This length is delta x. This length is delta x, and so on, right? So the Riemann sum tells us we're going to take the base times height. So now we need to figure out the height so that we can multiply them together. And this time we're going to use the right-hand Riemann sum. So we're going to take this height of the right-hand side. Okay, so we need to figure out how high this part is. Let me change color. This one is. That one depends on this point, right? It's labeled 1 right now, but let's say that it's unknown because of the way I slice this this rectangle. So I know this one, we start at A. So where is this point? That's supposed to be 1, but how? What is this point called? If this is A and I moved over delta x, so then what is this point? A plus delta x. Can you guys all see that? What about this part that says 2? How from A, how much did I move?
A plus 2 delta x.
Yeah, A plus 2 delta x. Can you guys all see that? Yeah? Okay, so I can kind of label it like that. So A plus delta x. This is A plus delta x, which is 2 delta x. And so on, right? And then I can label the rest of the points. Or I can also say that this is just x1, x2, x3, and so on. So instead of delta x, which I know how to get there by adding delta x, I can just say, I'm going to call this point x1, x2, x3. Okay? All right, now the question is, how high is this? Yeah, so this is f of a plus delta x, right? The function in terms of where my x value is. And this height is f of a plus 2 delta x. Or really, all of these, I can just say f of x1 and then f of x2. All right, and so on. Okay, so basically what we can do is say that the sum of the area is equal to base times height plus base times height. And we can do that forever until we get to the last rectangle. Base times height, base times height, base times height, and then we're going to add up all the rectangles. Or I can also kind of factor out that base because it's the same. So height plus height plus all the way down. So we talked about this, or at WSQ kind of talked about this the previous day. What will make this more accurate? What would make the approximation more accurate if we do what? Make more squares or make more rectangles, right? Basically increase the number of intervals so that it's very, very large, so then you have very small slices of rectangles. So to make this very accurate, we are going to make n go to infinity. Okay, so basically create so many rectangles that it's going to be very accurate. Before then, we want to write this in a summation notation. So basically, this is the sum of all of the rectangles together, right? So we have the sum of all of the bases times their, all of the heights times their base. And, I'm sorry, that is not an n, that is an I. And then I goes from one interval to n interval. To make this super accurate, I am going to make n go to infinity. Okay, and then notice that this is the height and this is the base. Okay, so this is basically Riemann's sum as the intervals go to infinity, which we are going to link it to integral next week. All right, for now, we are just going to leave it like that. I'm going to show you something else. So we talked about 4 ways to approximate the area under the curve, kind of roughly. One is the left-hand sum, or left-hand Riemann sum. One is the right-hand Riemann sum. One is the midpoint formula, or midpoint area. And then the other one is the trapezoid area. The other one we can do is called the upper and lower sum. So this is kind of interesting. So let's say that you have a graph like this, just some graph like that. And let's say you want to divide it into several intervals. Let's say 5 intervals. The upper sum means the highest amount you can approximate this by. So what you do is in this interval, you're going to take the highest point and then create rectangle. Yes? Okay? And then, so same thing, on the next interval, you take the highest point, whatever that is. It doesn't have to be the left or the right. It's just whatever is the highest point within that interval, and then you create a rectangle based on that height. Okay, next one, same thing, the highest point in that interval, highest point, and the highest point. So this is called the upper sum. This is the upper sum, so the highest values that you can get. The lower sum is the lowest point that you can get. So within the first interval, take the lowest point. The second interval, take the lowest point. Again, it doesn't have to be the endpoints. It could be somewhere in the middle. Third one, take the lowest point. Fourth one, take the lowest point. And the fifth one, take the lowest point. Okay, this is called the lower sum. Yeah. That part we are not calculating. So for this question, I only wanted 5 intervals from this point to where I drew the end. Okay, so let's look at some questions. All right, a car stops at a toll booth and proceeds onto the New Jersey Turnpike. The car's velocity at given points is shown in the table. Assume the velocity is increasing over time. Okay, so it tells you it's getting faster between 0 and 30, what is this, minutes? Seconds. As the car speeds up to enter the turnpike from an on-ramp. Okay, find the lower and upper estimate for the total distance traveled by the car over the interval 0 to 30. Okay, so they tell you the velocity, right? So they tell you the velocity and they want you to find the distance. Now remember that if you take distance and take derivative, you get velocity, right? If you go backwards, which is the antiderivative, you find position or the distance. Yes? Okay, so that means if you graph this graph, they tell you that it's increasing, so I'm going to assume it's something like that. This is the velocity graph. This is time. So distance is all the area underneath. So this is distance. We're going to spend a lot of time figuring out why that is next week, but for now, because we're going backwards, we're finding the integral, which means area under the curve. So when you have this function that's velocity, the area is the position or the distance. Good? Good, no good? Kind of. All right, so let's have you copy down that table first. All right, we are going to find the lower estimate first. Okay, lower estimate means within that interval, you want to find the lowest value. Well, this is not a continuous function, or they didn't give us a function, so we can't figure out if there are numbers in between that interval that is lower or higher, so we just have to take the endpoints. Okay, the first interval is between 0 and 2. Between 0 and 2, you're looking at the height. The height between 0 and 2, which number is the smallest? 0. And what is the base in that interval? 2. Okay, so 2 times 0. Okay, next, between 2 and 5. Between 2 and 5, what is the lower height? 2.2, and then what is the base for that interval? 3. So you see how the intervals are not equal size? So you have to kind of be careful whenever you have a table. All right, go to the next interval. 5 to 8. 5 to 8. Someone else who hasn't answered, so maybe over here. 5 to 8, what is the lower height? 4.5, and then what is the size of this interval? 3. So it's plus 3 times 4.5. And so on, and you want to finish up all the intervals and then calculate the area. So go ahead and do that. Okay, what'd you guys get for the lower estimate? Yeah, 370.1. All right, and then let's go ahead and have you do the same with the upper. All right, so the upper estimate, you're gonna use the same width, but this time you're gonna use the higher length. Okay, the answer is 464.2. So this is what you do for the upper and lower estimate. All right, let's look at another question. This one says, suppose radon gas is leaking into a basement at a rate of R of T liters per minute. Values of the rate at 10-minute intervals are given in the table below, in the table. Find the left Riemann sum and the right Riemann sum to estimate the total amount of radon that seeps into the home over the interval 0 to 60. Okay, so anytime you see a table, don't just assume you're going to create areas, or don't assume you're going to find derivative. Make sure you're reading the question. So it tells you that it gives you this rate. So this is a rate. They want you to figure out the total amount of radon. So basically, you have this rate that is liters of radon per minute, and you want to figure out the total amount of radon. So basically, you need to multiply by T. If you multiply by T, which is minutes, you end up with liters of radon. So this is a question that you do need to multiply and create areas so that you can figure out the answer. But on the test, a lot of times they give you a table. They will give you some information on the word problem, but what they're trying to test you is, do you know if you're looking for the derivative, or are you looking for the integral based on what they want you to find? Sometimes they give you a table and they want you to find both, and you just have to be careful with what the question is asking for. This one does want you to find the area, so go ahead and find a left Riemann sum and a right Riemann sum of this data. And this data is nice because it's every 10 minutes. All right, are you guys pretty much done with this one, or not yet? Okay, left Riemann sum, all you do is you take the left-hand side and you add up all the numbers except for the last one. And then this one, the base is 10, so you multiply by 10, 1.5. And then the right-hand Riemann sum, you take the right hand, so basically skip the first number, and then multiply by 10, 1.9.